for the area of a circle. Pi times the radius squared. Pi r squared. So area of a circle, pi r squared. Again, like I said, that's on that sheet of paper that I will give you for the test. I highly recommend you pull it up while you're doing homework just so you're used to using those formulas right in front of you. So we're just going to do a couple circles, find the area. Okay, this is not new information. You've done this, but it ties in with what we're going to do after this. So I just want you to be comfortable with finding the area of a circle. So here's my circle, okay? 10 right now, is that representing a radius or a diameter? That's a diameter, okay? So with a diameter of 10, if it's pi times the radius squared, what do you plug in? What's r?
5.
It's going to be 5. So the area of your circle is pi times 5 squared. Just to note, okay, for those of you that maybe get confused with all the pi's, it is not 5 pi squared. It's pi times 5 squared, right? The radius squared. And then your units are squared, okay? I think because you square the units, like inches squared, feet squared, sometimes people square the pi instead. Don't ever square pi, okay? Pi does not get squared. So this is pi times 25. We always write it with the 25 first and then attach the pi. Inches squared. Okay. So what's that second one going to be? 36 pi centimeters squared. Pi times the radius squared. So 36 pi centimeters squared. Okay, this one's a radius. This one's a diameter. Make sure you're always using a radius. Area doesn't have the two formulas, right? Circumference has pi d and 2 pi r. Those are the same formula in a different form. There is only one formula for area. It's got to be a radius that you're using every time, okay? Pi times the radius squared. Okay, so what that leads us to is a sector of a circle. And a sector is basically a piece of pie, if you will. P-I-E, not P-I, not the symbol pi. If you took a cake and you cut a piece of cake out, it's usually in that kind of triangular shape, right? It's this shape right here is a sector of a circle, okay? So what we're going to be doing is we're going to be finding the area of just that shaded region. Now think about what we did yesterday. We found the length of an arc, and we said it's the fraction of the circumference of a circle, right? It's a piece of the circumference when you find arc length. Area is a fraction of the area of the circle, okay? So the formula looks really similar. We say the area of a sector is going to be the measure of the arc. We're still going to just call it arc AB because we don't know what the arc is, over 360. But now instead of multiplying by circumference, we multiply by area of the circle. Pi times the radius squared. Okay, so that's your area formula for finding a sector of a circle. Yes, ma'am.
Are these formulas going to be given to us?
Yep, this one's on that sheet too. Okay, so this first problem here says find the area of sector ZOM. When it says ZOM, it's saying basically think of angle ZOM and shade that whole angle in. Okay, so sector ZOM is this sector. Okay, if we're going to find the area of that sector in terms of pi, we're just going to plug into this formula. So tell me what goes here, the measure of the arc. That's the 72. So you're going to say 72 over 360 times what? Pi times 20, the radius, squared. Okay, and again, a lot of people write this down for me and give me the wrong answer. This should be super easy. Don't complicate it, okay? When you get to this point, your job, that was Mrs. Burkhart's husband, your job is just to plug that in. 72 divided by 360 times 20 squared. Plug that into your calculator. What do you get? 80 when you plug it in. Then you can attach your pi and then label your units. 80 pi centimeters squared is the area of that sector. Okay. Okay.
When it asks for the measurement, that's the angle, like measure, like in degrees, right?
If it asks for the measure of what?
Z, like M.
Like arc ZM, if it asks for the measure,
72.
that's
But
72.
the length is the whole formula.
The length is the formula from yesterday. Yeah. The area is the formula for today. Yeah. Okay. We're going to take that idea and we're going to take it one step further. Okay. So this is a sector, right? Sector of a circle. We're going to talk a little bit about a segment of a circle. And it's a little bit tricky because it's not a segment. It's not a piece of a line. Okay. It's a segment of a circle. And here's how a segment of a circle works. You take a sector, okay, so you take this whole thing, you take away this triangle that is formed, and what you're left with is a segment, okay? So this right here is a segment of a circle. So if it says find the area of the segment, this is what you're doing. You're taking the sector minus the triangle, and it will equal the segment, okay? So we're going to do these two, and then we'll be done. Find the area of the segment here. Like we said, it is sector minus triangle. Okay, so I'm going to work right below that so that we're finding those things. So to find the area of a sector, again, you would have this formula sitting in front of you. The area of a sector is this formula, right? The measure of the arc over 360 times pi r squared. So measure of the arc over 360 times pi times the radius squared. Okay. What is the measure of your arc? What is the measure? What? 90, right? If the angle is 90, the arc is 90. So it's 90 over 360 times pi times what? 10 squared or 100, okay? Again, you're going to plug this into your calculator, 90 divided by 360 times 10 squared. Tell me what you get there.
25 pi just squared.
25 pi, okay? So 25 pi is the area of your sector. Now we subtract. Okay, so I'm going to subtract the area of the triangle. Now here's the deal, guys. I'm going to show you two ways you could do this right now. If you're looking for the easier way, well, that's not true. You kind of have to determine what's easier to you. If you want one formula that will always work here, it's 1/2 BC sine A. If you want to find the area of a triangle, however you want to find the area of a triangle, that one's a little easier on this one because in this triangle, if you do area equals 1/2 base times height, what are your base and your height? 10. The height is? 10. It's a radius, right? The radii are the same. But here's the issue. Look over here. Can you do 1/2 base times height on that one? No, because this is not a right angle, okay? So if you want to always use the same formula, it will always work to do 1/2 BC sine A, because you will always know your radii and you will always know that angle, okay? So if you want to play it safe and always use the same formula, stick with that. If you like doing 1/2 base times height where it's available, when it's a right triangle, you can do 1/2 base times height. The other side. This is the two, like legs, if you will, of the triangle. It's in the SAS setup, SAS, it's the S and the S, the two sides with the included angle.
Oh, right.
Okay, so just out of curiosity, who wants to do 1/2 BH right now? Who wants to do 1/2 BC sine A right now? Okay, so we're just gonna stick with 1/2 BC sine A. If you like the 1/2 BH, do it. It's great. I would do 1/2 BH right here just because it's an easy triangle to do it with. So 1/2 BC sine A in an SAS setup is gonna be 1/2. What's B? 10. What's C? 10 times the sine of what? 90. Okay. Now, if I were you, I would plug these in independently. Find the 25 pi, find the 1/2 times 10 times 10 times the sine of 90, and then get your answer. So 1/2 times 10 times 10 times the sine of 90 is 50. Okay, so if they ask you for an exact answer, this is your exact answer. You would get 25 pi minus 50 square inches. Okay, I won't ever ask you to give me an exact answer like that, but if the book gives you an exact answer, that is your exact answer. Okay, I'll just say give me to the nearest 10th. So you would just plug this in. Now you plug the pi in. 25 pi minus 50 is 28.5 square inches. Okay. Questions on that?
Where'd you get the 50 from? Like when you subtract 50, is that like 100?
That's 1/2 times 10 times 10 times the sine of 90.
And then where'd you get the 20?
25 pi was the sector. That was this. The area of a sector. So you're going area of the sector minus area of the triangle. Okay. Do you want to try the second one by yourself? Try it by yourself real quick. The sector minus the triangle, right? So the area of the sector is the measure of the arc. What's the measure of your arc? 120, right? This arc is what we're talking about, and that one is 120. So it's 120 over 360 times pi times what? The radius squared, okay? So we're just plugging it into that sector formula. This is that, okay? That's the area of the sector. I'm not even gonna simplify that yet. I'm just gonna leave it right like that for now. Minus, now the triangle, I would do 1/2 BC sine A to find the area of that triangle. It's the easiest route, okay? So you go 1/2, what's your B? 6, what's your C? 6, right? This is B, this is C, because this is your angle. So it's an SAS triangle, right? Side angle side is B angle C, okay? What is this angle?
120.
It's 120, right? The angle is the same as the arc. So sine 120 is what you're gonna plug in there, okay? At this point, you're done with the problem. Now it's just, can you do the algebra to get there, okay? And here's the beautiful thing. If you're rounding to the nearest 10th, do you have to put this in terms of pi first? You don't. You could literally plug it in how you see it in the parentheses right here. 120 divided by 360 times pi times 6 squared would give you the simplified version. I like it in terms of pi, so I usually simplify to terms of pi first and then plug it in, but you don't have to. So if I plug this in, I get 12 pi minus, then plug this in, that to the nearest 3 decimal places here. Remember, if it's not your final answer, don't go nearest 10th. You only want your final answer to the nearest 10th. So it looks like this, 12 pi minus 15.588. That's your exact answer, which is a terrible exact answer because it's rounded anyway, right? Which is why we don't give an exact answer on these. We usually just round to the nearest 10th. Because if you plug this in, 12 pi minus 15.588, you will get an area of approximately 22.1 square centimeters. Make sense? So sector minus triangle. Okay, area of the sector formula, that's this. Area of a triangle formula, use 1/2 BC sine A every time if you want. It will always work. Subtract them, 22.1.
So unless it's like the final answer, everything else gets rounded to
3, yeah, round to 3 decimal places until your very last answer. And then you can round to the nearest 10.
For any of the problems.
For any problem ever, yep. It's a best practice to make sure that your rounded answer at the end is the best rounded answer we can give. Okay, look what you get to do tomorrow. Rulers, pictures, dartboards. Oh, it's going to be so fun.